Welcome and hello. Today we are going to be learning Pythagorean Theorem. Now, Pythagorean Theorem was discovered a long time ago in Greece, and what it basically is a squared plus b squared equals c squared, where a, b, and c all represent sides in a right-angled triangle. Now, it is very important that they are right-angled, otherwise this theorem does not apply. It does not apply if the angle in the triangle is not a right angle. Now, A and B are the two side lengths that aren't the hypotenuse, also known as C. C is the hypotenuse, and the hypotenuse is always the longest side. A and B are also interswappable, so I could erase A and erase B, write A here and write B here, and it wouldn't make a difference. That's pretty cool about A and B. Anyways, here, let's have an example of Pythagorean theorem. Let's say A equals 3 and B equals, let's say, 4. Right? So, how do we find C? What does C equal? Yeah, that's right. We plug it into the Pythagorean theorem. So, it says A squared, our A equals 3, so we know 3 squared plus, what's B? B is 4. 4 squared equals c squared. Now, we know 3 times 3 is 9, right? And 4 squared is 16. So, what's 9 plus 16? Yeah, that's 25. 25 equals c squared. And we know that 5 times 5 equals 25. Therefore, c equals the root of 25. And thus, equals 5. So the triangle would look something like this. If we remove all the letters, because we know all the sides now, we have 3, 4, 5. Okay, let's try another example. I'm going to be doing this example in the video, but quickly pause here and see if you can do it by yourself. Okay, first thing we need to do is write down the equation. A squared plus b squared equals c squared. Alright, then we need to label them. We know this is the hypotenuse because it's the longest, right? So we will name this c squared. Oh, no, not c squared, sorry. C. And these two sides, remember previously we talked about, it doesn't matter if which side we call A and which side we call B. So let's just say 12 equals A and 5 equals B. Now, let's write it where we substitute the numbers for the letters, okay? 12 squared plus 5 squared equals c squared. Now, what's 12 squared? We know that 12 times 12 is 144, so let's write it like that. Plus 5 squared, which is 25, equals c squared. Now, the numbers used in this video are all quite easy to solve, but it's not always that case. Normally, you are allowed to use a calculator, but this video will contain simple numbers, so a calculator is not required. 144 plus 25 is 169, so 169 equals c squared. Now, if we put a root on both sides of the equation, we know that the square root of 169 equals c, right? And what's the root of 169? The root of 169 is 13. Okay, so c equals 13. Now, if we erase the question mark here, we can write 13, and that is that triangle completed. Now, let's try a harder example. This, okay, again with the same with the previous question. Pause the video right here and have a go by yourself. If you can't solve it, don't worry, I'll be doing it. Okay, so we're going to do the same thing we did in the previous example. We're going to write down the rule so we know what to do. A squared plus b squared equals c squared. Now, let's label which one's A, which one's B, which one's C. Now, this might be a little confusing considering this isn't a triangle. It's a triangle and a square. So what do? Let's draw an imaginary line here, dividing this shape into a triangle and a square. Now, we only have the c, or the hypotenuse. We know that c equals 5. But we don't know the other two mystery sides. We'll be finding x, so this side is particularly important because that's our answer. Now, first things first, we need to find this value, and to find that value, we just do simple subtraction. 8 minus 5 equals 3. So we know that this question mark is 3. Now let's set 3 to equal to a. Okay, we know the values for a and c, but we don't know the values for b, which is what we're looking for. So what we want to do is substitute the values in. 3 squared plus b squared equals 5 squared. This is basically what we've been doing in the past two examples, except we're flipping it. Instead of finding c, we're finding b. Now, this doesn't really make a difference. So, same thing as the previous examples, expand. 3 times 3, that's 9, plus b squared equals 5 times 5, which is 25. Now, if we minus 9 from both sides of the equation, we'll get b squared equals 16. Right? Again, root both sides, and then we'll get b equals the root of 16, and we know that 4 times 4 equals 16. Therefore, b equals 4. So this value is 4. Okay, that will be it for this Pythagorean Theorem video. But before I log off, I'm going to show you guys an interesting table. Now, these are called Pythagorean Triplets. Basically, what they are these are the numbers in a right angle triangle that will give you a whole number for the hypotenuse. For example, the 3, 4, 5 we did, 3 squared plus 4 squared equals 5 squared. You can prove it. 9 plus 16 equals 25. So all of these will give whole number answers, but just because they don't give you a whole number answer doesn't mean it's wrong. These are just the easiest to work with, and typically the first couple don't require calculators, but as the numbers get bigger, for example 24 squared, you would need a calculator. That is it. Thank you for attending today's class, and I'll see you guys in the next one.